Today we are going to continue with chapter 3. These are the answers for today's questions. Questions 1. Figure below shows a battery with EMF equals to 15 volt and internal resistance R equals to 4 ohm is connected to a resistance R equals to 6 ohm. A. What is the readings of the ammeter and voltmeter in the circuit above? B. Explain why the voltmeter reading is different from the battery EMF. To determine the reading of the ammeter and the voltmeter, we must identify what is the values that can be recorded by ammeter and voltmeter. For ammeter, we use it to record the values of current. How are we going to determine the values of currents then? Now, in these questions, you are given EMF and also internal resistance. Therefore, by applying equations for EMF, we have an equation EMF equals to terminal voltage plus IR. But we don't have the values for terminal voltage. So, we need to substitute V terminals as IR, where this R is the resistance for external circuit. And then these equations can be written as EMF equals to IR plus R. Factorize the I out, we got EMF equals to I bracket capital letter R plus small letter r. Substitute the values into the equations and you will obtain I equals to 1.5 ampere. For voltmeter, we use it to determine the potential difference between 2 points. In this question, we use it to measure the values of terminal voltage. Now, since we have the values of current already, so by applying the equations for EMF again, we have EMF equals to V terminal plus IR. Substitute the values into the equations and you will obtain V terminal equals to 9 volt. Alternatively, you can also determine V terminal by using IR, where this R is the R external, and you will still obtain V terminal equals to 9 volt. Why the readings of the voltmeter is not same as the values of EMF? Now, that is because when current flows through a source of electrical energy, the current experiences some oppositions known as internal resistance. Thus, voltmeter reading is smaller than EMF. Questions 2. 3 resistors are connected to a battery of EMF 12 volt and negligible internal resistance, as shown in the figure below. A. Calculate the total resistance in the circuit. B. Calculate the voltage across the 8 ohm resistor. To calculate the total resistance in the circuit, as usual, in step 1, I would like to label the diagram first. So I'm going to label the 5 ohm resistor as R1, 8 ohm resistor as R2, 6 ohm resistor as R3. Step 2. Simplify the circuit. So how are we going to simplify it? Let's look at the diagram again. So we have 3 resistors in the circuit. Now let us start from R1 and R2. If you look at the diagram, R1 and R2, they are arranged in parallel. Therefore, 1 over R12 is equals to 1 over R1 plus 1 over R2. Substitute the values into the equations. You will have 1 over R12 equals to 1 over 5 plus 1 over 8. Rearrange the equations and you will get R12 equals to 40 over 13 ohm. let us continue with step 2, simplify the circuit. After we simplify R1 and R2, now we are left with R12 and R3. Now, as you can see in the diagram, these two resistors, they are now being connected in series. So to calculate R total, which is the R equivalent, so Req is equals to R12 plus R3. Substitute the values into the equations and you will get R equivalent equals to 9.08 ohm. Questions B. Calculate the voltage across the 8 ohm resistor. How are we going to solve these questions? Now, step 1, let us do the reversing process by using R total and V total to find the values of the I in the circuit. Because as you can see in the diagram, now these three components, they are being connected in series. So by using VIR, we have 12 equals to I times 9.08. And the current flowing in this circuit right now is equals to 1.32 ampere. Now that we have the values of current, so step 2, let us determine the V across R12. So this is the diagram of right. So to calculate V across R12, we use V12 equals to I R12. So V12 is equals to 1.32 times 3.08. And V12 it is equals to 4.07 volt. So once you have V12, now let us look at the relationship between V12 and V1 and V2. So since R1 and R2, they are being connected in parallel, so therefore V12 it is equals to V2 and it is equals to 4.07 volt. So that's all for today. I will see you all again tomorrow.